Happy Monday, everyone. Venkat, welcome. And Joe, welcome from the airport. This is a somewhat
Hey,
unusual
how's it going?
venue for you to be broadcasting from.
Yep, home away from home these days. So
Yeah. And
good
Venkat,
to
I'll
see you,
let you
Venkat.
introduce yourself. So obviously, you're CEO and co-founder of Rockset. I'll let you give your own intro. Actually, go ahead.
Thanks, Matt. Thanks, Joe. Great podcast. So thanks for having me here. It's a pleasure. I'm Venkat. I'm the co-founder and CEO of Rockset. At Rockset, we are building a real-time analytics database that's built for the cloud. Prior to founding Rockset, I was at Facebook, where I was managing online data infrastructure. It was called Facebook back then, and I was there from 2007 until 2015. Helped scale the online data backend there from 30-40 million monthly actives to 1.5 billion users. And just like last week, they announced they have 2 billion daily actives, which is amazing. And so, learned a lot and scaled a lot of systems. And TLDR is, we saw the transition from batch to real time within the boundaries of Facebook. Built a lot of amazing, large scale, efficient, database management systems for that to facilitate that. And here we are trying to do that for the rest of the world. By building, cloud native, built for the cloud, born in the cloud, real-time databases.
Well, if I understand correctly, also you worked on Hadoop in the early days of Yahoo, right when Hadoop was getting started, and so that's quite the journey to go all the way from like this heavy hitter batch big data system to like the cutting edge of cloud real time. Maybe you can tell us a bit more about that journey.
Yeah, I mean, my co-founder Dhruba Borthakur is one of the people who started the Hadoop file system project. And so I've worked with him closely on that on many different occasions. There was not, in at Facebook, there was not the direct team that I was managing or I was responsible for, but is intimately aware. I worked very, very closely with these people through these years. The transition, I think, is, I mean, I've told this story in other places, but I think the real transition that I talk about is when in 2007, when I started at Facebook newsfeed was a batch system. We would basically do the equivalent of an ETL job. We'll crawl around everybody's activity in all of these databases, and then build everybody's newsfeed. And then you get to see that in the morning, like a newspaper. Get a fresh, make some coffee and read your newsfeed, and then come back next day. That's what it used to be. And only in circa 2008, Facebook newsfeed went real time, where activities happening as and when they happen or getting indexed in real time. And then you get a personalized feed on top of that, and then the ML layer was added on top of that, and the rest, as you say, is history. And one of the systems that underpins the Facebook newsfeed backend is called RocksDB. So we built that and we open sourced it somewhere around 2012, I think, 2013, and we spent at least a few years before that building it. And so that is kind of like we were being very closely involved in these kinds of real-time backends. And so I think the transition has been really amazing to see. And earlier it used to be some fringe use cases, niche use cases need real time, and it's amazing to see that basically going mainstream now.
What kind of impact did you see at Facebook when the newsfeed went from like the once a morning newspaper batch to real time, constantly updated based on your clicks and preferences and experiences?
Yeah, I mean, it's the most, like, the biggest metric that we used to measure was engagement, and that was what went through the roof. It's like you have a reason to log into Facebook more than once a day, right? You have a reason to go and look, hey, what's happening now, kind of a thing. And so you start essentially having much more engaged power users, and that are constantly trying to engage with content that just got created within a matter of seconds, since it gets created. So I mean, I used to worry a lot more about not the product impact, but like the the backend data infrastructure impact every single time. If we would launch even simple things like putting a like button or putting a like button next to not every content but every comment, would completely transform the load on the online data backend back in the day. And just to give you some estimates, I mean, these systems were serving 5 billion queries a second collectively, right? And now it has gone to like 40 billion queries a second. So the scale we're talking about is just so big that every product launch, if it changes the workload dynamics significantly, just like how you scale that has been like was our first and kind of primary responsibility, and that was a lot of fun that we were able to launch like in the hyper growth years, like so many amazing features that really made Facebook so prevalent and so successful. And I would say the online data infrastructure team just did an amazing job in facilitating that, and also making sure it doesn't go down all the time, as you're scaling and adding not only a lot of features but also a lot of users.
Well, and the load spike issues you now have to deal with are just incredible. So a couple of years back, I was reading an article about what the Facebook team had done to prepare for people saying Happy New Year right after midnight in each time zone as the new calendar year rolls around. But even scarier is like the unanticipated load spikes. So every time a big piece of news lands, like say there's a balloon spying on the United States, or there's something like this, some political news, or a celebrity passes away. These things happen on a regular basis, but every time you can have huge load spikes hitting your systems. Like how do you think about those issues? Not just scale, but like how do you think about, okay, what is my 99th percentile load spike and how am I going to cope with that?
Oh yeah, I mean, it is. So back when 2007, 2008, when I was there, Facebook was doubling in size every 4 months, roughly, and then it became every 8 months, and now it's like every 6 years or something. I don't know, but back it was even harder. I think these shifts that you're talking about used to be not a 5% swing or 10% swing. Even that I think could be very bad. It could be a 100% swing. Everything just doubled, right? Like the number of
Oh,
people
wow.
that are, yeah, and that I think was actually very hard, right? I think to deal with, and so how would we used to deal with it? I think so early days we would have all these compute intensive parts of the application that we would have all these kind of like gates, all these flags, feature flags that we would have that we would actually go and turn off. So we would, that is the only way, because we have to release some load from the system so that it can handle all these other people logging in. And so everybody will get like these slightly, or if somebody comments, you won't get immediately see it, or how often things get refreshed. Things go maybe from like up to the second accurate to like up to the minute, and so it kind of like there isn't really that much new content constantly coming for you to engage. And like buttons will disappear from like comments, but it'll be right next to the content. There's about
What?
there's about 500 of them. So we would do those things just as like a way to release some pressure, and that is the only way we could do, because Facebook data centers are planned years ahead of time, right? It is not, we are not in the classic kind of public clouds, so we can't just go and turn around and saying, hey, AWS or GCP or Azure, give us more machines for the next 12 hours. We can't do that. And so there is really, the capacity is pegged at what is available, and we really have to kind of like do a lot of interesting things. So oftentimes it is always like some functionality that is stressed and some part of the backend is stressed, and that part of the backend we would have a bunch of release valves. And so like, okay, release this, release that, and then we'd go, all right, now we can at least stay afloat, and then we'll be constantly monitoring it, maybe hotfix a thing or two to try to make that part that was super expensive a little bit more efficient, and then try again to kind of like bring back all the functionality that people lost for like maybe 20 minutes.
And so really you're talking about like cascading graceful degradation where you start degrading service, but maybe in a way that people won't notice right away, where it's kind of like back-end analytics. You're not quite as real time as you used to be. Now it's 1 minute versus 1 second, which 1 minute already is doing, you're doing pretty well.
Exactly.
Interesting.
Exactly. And then later on, it just evolved. Later on, like, circa 2012, give or take 10 years ago, Facebook already had multiple data centers that they had already built at that time. And so it would be about directing traffic to to extract like the maximum efficiency and sharing that, because you don't want all of that to for whatever reason get directed disproportionately to like one data center. And so there would be a lot of global load balancing that is going on that would give us like more. And so it's all about having a bunch of these ahead of time. Much later than that, in the mid 2010s, I think Facebook started getting extremely good at this. So what Facebook started doing was periodically making every data center, every cluster, every network that we have internally. We used to call them clusters. Every one of them, we would put them on overdrive, even when there is no load-induced upscales happening. And so we would immediately find the weakest link in every setup, and then we would go and say, all right, like, clearly if this actually happened, so and so this service is not ready, you gotta go and come back. Because a lot of the time you think about the web app or the mobile app and the core backend for that, but there are real-time systems fighting spam. There are real-time systems tracking ad impressions. There are real-time systems. All of them also have to work in conjunction. And so when a lot of traffic goes up, all of those things are also stressed, and oftentimes something on the side becomes the bottleneck. And now all of a sudden you can't use all the capacity that you have on your main stack, because one of these supporting systems isn't able to scale. And the only way to find that is to actually push it to overgear, just put all of that workload. And our global load balance, at Facebook, just had tremendously amazing people, working on the data center teams, both on the software side and the hardware side, and global load balancing team. These people were just incredible. And so they would just go find these things and proactively figure these things out, because the last thing you need is figuring those kinds of complex things and updating your BGP settings when there is a site outage.
And to what degree was this automated? So it sounds like you were constantly just hitting your systems with like various tests, just throwing extra traffic at them to find the weakest links. Did these processes become extremely automated, or were they still pretty manual?
Oh, this is all super automated. I mean, I think by the time I was leaving Facebook in the 2015, 16s, like, I mean, a single person couldn't even find if they have like 3 weeks of time, if something isn't scaling, if like a particular cluster isn't scaling to 100% capacity. Like one person wouldn't have the knowledge to go and know what graphs to look at. And so there was an amazing team that just kind of pulls all of that together, and that is all they were doing. They were not actually building any of these supporting functions, but just making sure that we have everything to be able to manage the load characteristics of a large data center when it is not running, when there's more and more user traffic going there. So no, there was tremendous amount of engineering. This is like engineering, like classic large scale distributed systems engineering. And yeah, it was not easy. It was the only other company that I know that does that at that scale really, really well is Google. And that was the only precedent that we had. Google would do back then. I mean, I'm sure this team has evolved. I haven't worked at Facebook for quite a number of years now, but back in even 2010s, Google would not only do these kinds of increased load testing, but they would also just go and take out an entire region, entire cluster, and make sure that things are still working. And so it's chaos monkey testing at like at 10,000 feet. Like it was really amazing. And they set up. They found a lot of best practices on how to do these kinds of activities in planning, and definitely I think we exchanged some notes. But scaling search and scaling a social network are very, very different things. So there are some fundamentals that I think you can learn from them, but we still had to do a ton of things that other backends didn't have to worry about.
And along the way, speaking of backends, RocksDB came about. You want to talk about that? Sorry, I'm at the airport,
absolutely. So the joke at Facebook in, let's say, 2010, 2011 used to be, oh, you're a new engineer who just joined Facebook, and in the first 6 weeks, they go through this thing called boot camp. And then we'll joke about it and say, all right, like, okay, you just graduated boot camp, go build a key value store. It's like, so the joke used to be that essentially this massive movement from batch to real time was happening. But internally, Facebook had very well-established kind of platforms for online data, which is what my system was doing, which was the canonical data store. I need a place to store the canonical source for like users and friends and photos and photo tags and like just the core data, right? Like the important data that makes up this the user data for running the site and running the app. And then the batch was also very well established. We talked about Hadoop and Hive and a lot of Presto came out of that team. So that was also a very good platform where if you just need batch data, you're covered. If you needed system of record kind of data, you're covered. But then there was this plethora of, I'm literally talking thousands of services, not even hundreds, that were stateful services that needed to manage some kind of state. Maybe you're aggregating ad impressions. Maybe you're indexing user activity for newsfeed backend. You're tracking all links that are shared by anybody to know which ones are spam so you can fight them. So there's like all sorts of real-time systems were being born. But there was, in the early days, Facebook didn't have a general purpose system that people could just use to build those kinds of applications. And so we were thinking about how to facilitate, how to enable them. And it has to be extremely performant, these kind of data backends, and it has to work at massive scale, and it has to work in real time. And so RocksDB was born out of simply the need to build, to make all these stateful services and real-time services and real-time apps people were building, to make that easy by building a storage engine that could be embedded across the entire space of online and real-time data management. And we tried a couple of different approaches actually before we settling on RocksDB. Right around the time Google actually open sources this key value store called LevelDB, which was extremely, it was really amazing. I think it was like, in terms of like, if a program is art, I think LevelDB code should be in like the museums or something. Like it was really beautifully crafted, very, very well written. But it was really built for embedded storage on browsers and mobile devices and those kinds of like, not large scale server software, server storage, but it was really built for, LevelDB was built for other, more lighter weight kind of applications on the client side mostly. At least that's our understanding. But we took it and made it work at massive scale at server on the server side for actual data servers and data management server storage. And so by the time, I think right now it doesn't matter what online database is being built at Facebook. The storage engine behind the scenes is RocksDB, from the online data store to newsfeed to spam to ads. Almost every backend, if I recall, is essentially using RocksDB as the storage layer.
This is kind of a crazy evolution, though, to go from an embedded database, which almost sounds like a way, way more advanced version of SQLite, but basically like this light local database that runs in a browser, to like this hyper distributed state management system that can run across the scale of Facebook. I'm curious. I'd love to talk someday about how that came about. I have no idea if you can speak to that, but how someone said, let's choose this and evolve it into this like massive scale key value store.
Yeah, so I think the RocksDB to Rockset, I think is that story. I think RocksDB is still an embedded key value store, except that it's built for server side embedded, and so there is still a lot of the upper layers of your distributed system that still had to be built. And within the boundaries of Facebook, every one of those things was special purpose. That was not general purpose, right? What this particular system was specifically built for newsfeed, and it doesn't do anything else. This other one was specifically built for ad, impression aggregation or something like that. And this was our key realization, that a lot of these people are writing custom C++ code because they don't have a SQL engine that works in real time and that is very, very performant. Because writing a SQL query versus writing C++ code to do the same amount of work, it's like, one, you can do one in a matter of seconds. The other one takes weeks to months, if anything. And so that is the real transition. So, RocksDB is still the storage engine behind Rockset. And if you, but at this point, RocksDB is neither necessary nor sufficient for Rockset. Rockset has a real-time indexing engine that is completely that connects to data sources, brings data in real time, and turns them into SQL tables. And it just happens to store that in a bunch of locally embedded RocksDB instances. And Rockset also has a distributed SQL engine that will take in a SQL query, shred that into a bunch of fragments, schedule that across the entire backend, which is a distributed backend, and the execution will start in about a millisecond or so, and start running a query and make it very, very fast. And so a distributed SQL engine that is also built for real time from scratch, we have also done that. And so it's a combination of a real time indexing engine, RocksDB Cloud, actually, and the SQL engine. The combination of that, the three of them, is what makes Rockset work. And so yeah, RocksDB is still a key part. At Rockset, what we did was we took it and made it work even better in the cloud. So it uses S3 as the backing store, as opposed to some other, just using local persistence, and that allows that gives you even more flexibility to build these kinds of stateful services in the cloud. And so we built RocksDB Cloud, and it's open source. And on top of that, we build the indexing engine and the SQL engine, and together, all of them, they make up Rockset.
Well, maybe that leads me into another question. So I think a lot of the purpose of Rockset is to provide this abstraction layer. You were talking earlier about the scaling issues you were facing at Facebook, now Meta. But if I'm a new engineer and I'm going from batch to real time, to what extent do I need to think about these scaling issues? Are you able to remove most of those from engineers, or are they still going to have to think about hard scaling problems that come up in a real time system?
I think it's a great question. I think I've thought a lot about this, right? I mean, the classic thing that I always say is, if you go ask 100 people, do you want 2-day shipping or next day shipping or 5-day shipping? Everybody's going to say, give me next day shipping, right? But there are two times when they'll say no. Number one, if you ask them to pay more money, shipping fees for that, they'll say, never mind, 5 days good enough. Or if you ask them to go, rent a U-Haul to drive to the edge of town, they'll say, just deliver to me, 5 days is fine, right? That, I think, is the crux of batch versus real time, right? I think if real time has a cost barrier or a complexity barrier, then people say batch is good enough. A lot of the time, people don't say batch is great, batch is all I need. They'll say batch is good enough. The only time you settle for good enough is when the alternatives are either expensive or clumsy, right? And so if you think about it from that vein, the key realization here is that why is real time expensive and why is real time clumsy? And that is the crux of, I would say, what underpins Rockset in terms of both vision, core R&D that we have done. Our fundamental thesis from the very beginning has been that we have to completely eliminate all cost and complexity barriers for real time for that to become more and more mainstream. And so that has been a singular mission since the very beginning. And there are two important, I would say, approaches that we have taken, strategy we have taken. Number one is completely cloud only. So we're not cloud native, we're not just a software you can download, install, and it also happens to have a managed cloud service. No, we're cloud only. In some ways, what Snowflake did for batch, we are trying to do for real time, right? I think it's about being only in the cloud and exploiting every flexibility and efficiency tactic you can get in the cloud to make real time at massive scale very, very efficient, very, very scalable. And so that's the crux of one big approach, which is being exploit the cloud and make it and eliminate all the cost and complexity barriers. The other one that is even more foundational is databases. For as long as I know, I've been building databases all my life. We're largely falling into two categories. Either you build a system of record transaction processing database. If it's not for transaction processing, I don't even need to ask you more questions. I'm sure it's a warehouse. So we always had this hypothesis right from the very beginning that the world of data is missing a third leg. As real-time data acquisition becomes more and more mainstream and real-time becomes the new normal, the new default, there are going to be data management systems built and optimized from scratch, and every line of code written is optimized for real-time use cases as opposed to either transaction processing or batch analytics. And those are the two, I would say, fundamental tenets, that fundamental strategies that we've embraced on how to approach real time in the cloud and make it a lot more scalable, efficient, and user friendly.
Well, this leads me right into another question. I think you guys have told a fantastic story in terms of simplification, and that means like lowering labor costs, lowering technology costs, lowering technology risk of things going down, because now Rockset can take care of a lot of those details for you. There are other competitors who've done the same thing, I would say, although you have like a unique flavor and take on it, which is very compelling. But we're still seeing this lag on actual team adoption of real time. And we talked about this a bit before we kicked things off, before our audience joined us. So what are the barriers for teams actually adopting real time if the tools have gotten simpler? What's preventing people from transitioning their data warehouses to more of a real time paradigm instead?
I think it's the best the real reason, the real question is like, why now? Or like, what are the barriers to adoption? And if you think about it, how many years after people are walking around with a GPS in their pocket can a Uber exist? How many years after businesses are acquiring valuable, important business data in real time can a Rockset exist? I think that's the correlation here. I think Rockset cannot exist if businesses were not already acquiring really important business data in real time. I think that happened. Kafka, Kinesis, and all these kind of data streaming technologies going mainstream in the last, let's say, 5 to 10 years has really created that need, where what people were doing was, there are still a lot of people still doing is people acquire really critical, data in real time through Kafka, let's say, or Confluent Cloud or what have you. And then they still drain it to their lake or warehouse because that's the only thing that is big enough to be able to hold that torrent of data coming in. And then they would still use these kind of batch-based approaches to turn them into insights and intelligence and what have you. And now organizations are turning around and saying, what am I doing? This data actually came into my backend, 12 hours ago, 6 hours ago. And had I known that something was going off and somebody, alerted right then and there, I could have prevented this. Like, why are you telling me that we lost the game if you tell me that in the middle of the third quarter, not at the end of the game, right? Like, because this other thing mattered and I wasn't paying attention to that. And so that, I think, is where the businesses are going. Now that we already have this, all this data getting acquired in real time. So that, I think, is the crux of what's happening. So then if you go to any data team and you tell them, oh, now there's more data coming in real time, manage it. 9 out of 10 data teams, what they would do is they would use existing systems to try and push it to the point of, good enough. Yeah, this is good enough and this is fine. Yeah, I'm sure, these batch data warehouses that I'm using, cloud data warehouses I'm using, is not really built for real time, but, I'm going to keep pushing. see where it breaks, and that's one big source of both cost, and it becomes very expensive very quickly, and it's also one big source of complexity, where now suddenly, in real time, data loading is not happening once a night where, oh, there's this ETL job that broke and next day morning you can come and wake up. It's running 24/7. So it has to have a level of engineering. The systems that you're sending data to in real time has to have a level of agility and adaptability so that it allows you to build reliable real-time applications. And so the first generation of all real-time apps, in my opinion, were built by people either misusing Elasticsearch, because that's that's one Swiss Army knife I have. I'm just going to throw Elasticsearch at this thing. I'm not doing natural language text search, which Elastic is very good at. I'm not doing log analytics like the Elk stack for my error logs that Elastic is reasonably okay at. Oh, I need a real-time database. Oh, but you know what? I'm gonna try and see if Elasticsearch is good enough. Is my cloud data warehouse good enough? And that is really where people started, and now everybody's outgrowing that, either because they can't scale it, and it takes too many people, it's too slow, and it's too expensive. And that is the crux of why we built Rockset, which is to build a real-time database that takes these workloads and not only makes it easy to operate, administer, but extremely efficient at scale.
So let me ask a follow-up question. And this is part of a much broader discussion, I think, about data engineering training and education. What specifically should we be doing for training and educating data engineers, both new engineers and people who have an established career, to help them make this transition to real time?
Yeah, I think what is the education thing? I think the when I think about it is to transition to real time. I think the one of the key realizations that people need to have is that it requires a different kind of a data stack, right? I think if you are, people are so used to picking databases not because it's necessarily is the best thing, because they're picking the most familiar thing that that they've used in the past. And in many applications, whether you're building a mobile app or a web app, right? Like there may be some reasons to use, let's say, MongoDB instead of Postgres. But if you're so familiar with Postgres, you can't really go that wrong. It's fine. It's an amazing database. Or MySQL, right? Like it's an amazing database. You can be a little bit wrong, but you can't be completely wrong. But that's not the case in real time. These are all applications where the data never stops coming at massive scale. And in every real-time application, you also have to think about query performance and query scaling. So really, I think it's so easy. I think for real-time to backends to kind of like get sucked into making the wrong data stack choice. So that I would say awareness of that, I think, is probably the number one thing. That hey, this hammer that I'm using, are not made for these screws. It's like it's a different. I need a different tool for this whole category of applications that I'm looking to build. I think that would be the first thing. The second thing I would say is when data is constantly coming in warehouses, typically, especially with the ELT layer, you load the data and then you do transformations on them and then you do analytics on them. In real time, it often gets split in what transformations and unprocessing you want to do before the data gets loaded and stored. And that is a very important concept. And you can't, because the raw volume of the massive torrents coming in is so enormous that if you try to drain all of that data into the small cluster, it'll immediately become a reservoir, right? Like in no time, it'll have so much data that you kind of don't want to really store the raw data feeds, unless, you could still store it in some batch system for like an opportunity cost for like future, analytics, just in case kind of a thing. But for the core applications you're building, it is very important to be able to translate that raw data, transform that raw data as the data is coming in, into real-time metrics and real-time statistics that you can keep track of. So you kind of want to really only store the first order derivative as opposed to the actual raw data, and you need to be able to do that on the stream itself without actually storing the stream somewhere and then doing all the calculations on top of that. And so we call it incremental metric calculation. So every time another record comes in, you basically say, oh, I'm keeping the total amount of payments processed. So I'm going to just turn this, into adding whatever the invoice amount was to this total metric automatically, so that I don't have to, store the millions and millions of records, raw records, but I can kind of get a first order derivative, which is sums and counts and aggregations and other complex functions that I want to run on top of the stream, but I only want to store the derived data. And so that, I think, is another very important thing to remember. And the cool thing about Rockset there is that you can do that simply using SQL. So the third thing I would add that is, you should also demand more from your database. If some system comes around and says, oh yeah, we can do all of these things, but we don't have, but joins, don't talk to me about joins, or aggregations and window functions. We kind of have something that's quote unquote SQL-like. Anybody that says they have a SQL-like API don't have SQL, right? So so that's like, if you hear the word SQL-like anywhere, be extremely skeptical that it is actually, whether it is a powerful analytical system or not. You never hear the word SQL-like when people talk about Rockset. It is a full-fledged, full-featured SQL database that's built for real time, and you can use SQL both to transform the data, as I was talking about, before it gets stored, and also you can have different streams and different metrics stored in different tables, and you can join, aggregate, and do whatever, all analytics that you want on top of that, like you would expect from any performance SQL database. So these are my big takeaways. I think, it's so easy to make the wrong choice. Look closely on what your needs are and pick the right tool for the job. Understand that compute here is split between two parts: compute that happens on the stream and compute that happens for query processing. And they are kind of like two important parts of every real-time app. And demand SQL. Otherwise, don't inherit complexity that is implicit. Because your backend doesn't have SQL, you end up writing thousands and thousands of glue code that you should not be worrying about. And that just adds tremendous complexity, and don't fall for it.
So let me ask you this about the SQL part. And so it's not just the SQL language, but it's really what I would call SQL semantics. In other words, you have something that sort of resembles a relational or at least a semi-structured model, and you support things like joins and aggregations and filtering and such. Did you start out that way when you set to work on RocksDB, or was this a later realization that, hey, we need to have a lot of these semantics right out of the box?
Yeah, actually, before we came out of stealth even, we had a couple of co-development partners at Rockset, way early on, just friends they were not customers. They were really, just say, hey, you have something, I'm going to go. And we did not start with the SQL. We started with something that was SQL-like. I mean, this is pre-stealth. I'm talking even before the company was founded, when we were researching the space and what have you. And we thought the value prop of real-time is so compelling that people would not be demanding, the difference between what some other simpler API versus SQL was good enough. And very early on, we realized that was wrong. Because I think what had happened was, in the last 5 to 10 years, as I said, business data is getting tracked in real time, right? Prior to that, there was a lot of real-time systems, except that they were doing logs. And the one thing that you don't need in logs is joins. It's almost like what you need is distributed grep. You don't really need joins on logs to figure out, has this error happened before, or when did it start happening? You're not really joining that with some other dimension table that you have that is important for your business. And so a lot of these systems thought the value prop in real time was good enough that you don't need all of this stuff, and people will jump through hoops, except that it never went mainstream because of all of those barriers. And we realized that we needed a full-fledged SQL. And so SQL, just like how SQL can be used across as the same lingua franca, whether it's Postgres and MySQL for system of record transaction processing, or a cloud data warehouse on the other end of the spectrum. SQL, I think, continues to be and has to be to also the lingua franca for real time. I don't think fundamentally the questions that people are looking to ask of their data to make better decisions fundamentally still needs the sophistication that SQL generally gives you in terms of joins, in terms of manipulating data and modeling data, turning data into views and so on and so forth. So all of that, I think, is really needed. Those are all fundamental building blocks on top of which you can make sense out of data. And if you don't have those abstractions, if you don't have those mechanisms to do joins and aggregations and window functions and what have you, you can still it'll just become very cumbersome, right? Like a simple SQL query that takes 30 seconds to write and 1 second to run, you can go and write like a piece of Python code or whatever to do the same thing. It'll just take you a week, to make sure that you're doing the right thing, and that just means you can't iterate quick enough. And so if you can't iterate quick enough, your iteration speed is many weeks. You probably don't need real time, like you.
Yes, you can't answer. By the time you try to answer the question, you're on to some other question,
Exactly.
right? Like, yes, the data is real time, but the queries are not real time.
Exactly. And that's why the queries have to be extremely fast, 100%, right? Like, so this is why I think the modern kind of like really innovative organizations that we work with, they seek for this. We have had companies come to us and say, we have a 6-hour blind spot. So they already don't do nightly jobs. They have a 6-hour blind spot where something goes wrong in their business, they don't know immediately. And that 6-hour blind spot is bad because if a really bad outage happens, they miss their quarter. And they come to us, they plug all the business critical real-time data. Now they can monitor that in 1 to 2 second lag. They run their automatic detectors every minute. And now their blind spot has come down from 6 hours to 1 minute. Within 2 months of launch, they early detected incidents that would have had such a bad downtime that they would have missed their quarter had that not been detected for 6 hours. And they've embraced it even more. Now there's 5 times more data flowing through Rockset in that in that situation, in that customer, and they're protecting more and more parts of their company and their product with this infrastructure. So yeah, I think real time is here to stay, and I think SQL has to be the lingua franca of it.
And I have a comment, then a follow-up question. And I think what I've seen in general with real-time projects, kind of going back to what you were saying earlier, it's always the complexity and the unfamiliarity that kills these projects. Like, even if they get delivered, they don't get used because they're too complicated. So for example, you'll start out with like CDC from a production database. Oh, now I need to buy a CDC system to connect that into a streaming buffer. So they go buy the CDC system. Oh, now I need a cloud function, or I need some other system to now get that into a target database. And it's just all these bits and pieces that kill these projects. And so the more accessible you can make this, I think the more widely we'll see this be deployed. And here's my follow-up question, though. If I'm an established company, and so say like this example you're talking about, and I have these 6-hour blind spots, and I'm like, hey, I really need to transition to get rid of these like 6-hour delays that are costing me a lot of money. Where do I start? Do I start by saying, okay, let's identify one use case, let's keep our data warehouse but spin up real time? Or is it, no, I really need to rebuild my entire infrastructure from the ground up to take more of a real-time paradigm? Like, is there a one-size-fits-all answer, or does it depend on the situation?
Oh, it's absolutely the former. I mean, even if doing the latter is the right answer eventually, like, because your entire company runs like in real-time operational kind of intelligence is the key, you still want to start with one use case. So like I would say that's a great way you phrased it, which is like, do I start with this one use case where the ROI is going to be very high? What we see with our customers is that is how everybody starts, and that is the right way to start. Sometimes customers will come to us with like 3 or 4 use cases at the same time. Even then we'll say, we can win, let's go nail one, and then we can do the other 3 or 4 you have in parallel. That's okay. But getting the first one right, I think, is really, really important. So Rockset, we always think about real-time as an augmentation play. It's not here to replace your batch systems. It's not here to replace your transaction processing systems. There's a bunch of databases out there that under the HTAP umbrella. We are hybrid transaction analytical processing. I'll very, very proudly say Rockset is NTAP. It's neither a transaction processing system nor a batch warehouse. We're neither, and we take a lot of pride in that because we're built for this one real-time analytics workload that we are very, very good at. And so, if you don't want to settle for less, you should demand more from your database, and we can do that. And so coming back, how do you start? Yes, I think you start with this one place in your business where extract-based, batch-based reporting is not good enough. Or let's say you're building a SaaS product and you're an ISV, and you need to build end user facing analytics, analytics that your end users are interacting with. You could have a massive multiplayer online game and you're building, leaderboards, that is, user facing. You could be a big SaaS platform, and every SaaS product that you use probably has an analytics tab where users can come and look at their usage of the platform and slice and dice the data in real time. So to power that part of your product is another example. So in any of these cases, I would say start with one place where you not having a scalable, efficient real-time database is hurting your business. Either it's creating a larger blind spot than what so you want to go from BI to like operational intelligence. And so that I think is a very good place to start. Or you're already building an application or a product where a part of it requires sophisticated real-time kind of slicing and dicing, and start with that use case. And there is another related question that came in the comments that said, what are the good patterns for data ingestion? And so the best pattern for real-time data ingestion is to not have a broker in the middle, right? Somebody that is, you have Kafka, you have Kinesis. The whole point of Kafka is it's pub sub, right? You can have producers and consumers independently, reading and writing into the stream, and they can scale independently and don't have to synchronize with each other. And that I think is a very, very key pattern. And so Rockset comes in with built-in data connectors. So it has these suction cups. No code is required. And the best pattern that works is take Rockset and take the data connectors and connect it directly to the data source that is like Kafka or Confluent Cloud or Google PubSub or what have you. And that allows the Rockset ingestion platform to kind of elastically connect to your data streaming platform. And then you eliminate all data lags in the middle, and you eliminate all complexity in the middle. And as a user, writing to Rockset is as simple as you writing to your existing data system, like whether it is Kafka or Kinesis or PubSub. And that I think is a very, very important element to making real-time operation, to contain the operational complexity that typically ends up coming. Because the minute you have even a simple webhook or anything in the middle, now what happens if system A, which is here, Kafka is up, and system B is unavailable, which is Rockset, or the other way around? What do you do? And how? And then suddenly you have all this complexity, snowballing into this little kind of like glue logic, and it'll never do the right thing because it just cannot seamlessly adapt to ever-changing workloads and flash floods of data. And suddenly, let's say there's a lot of data in Kafka, you kind of want to spin up more compute and more, on the ingestion side. And Rockset can automatically do that for you. It's serverless and easy scaling, and you can easily auto scale these things. And so that I think is kind of like the right pattern where you want the data streaming, ingestion time transformations and storage and query time transformations and compute needed for all of that, and storage needed for all of that to kind of seamlessly scale with kind of like changing workloads. So that is the kind of setup that you should be looking for in terms of an ideal scaling pattern.
So basically loosely coupled systems where each component of the systems can scale independently and can like have some built-in resilience as well.
100%.
Okay, here's another question. We actually, I would say a theme for 2022 into 23 has been data modeling, and we actually were talking about, so about a year ago we had Shruti Bhatt on, who is your SVP of marketing and chief product officer as well, like really amazing lead at your company. We were discussing this issue, like, if I'm thinking about real time, how do I think about data modeling? Because I would say that a lot of our data modeling paradigms are built around more of a batch approach. So what's your outlook on that?
Yeah, I think no, it's a common question that gets asked. I would say, once you know that you have full feature SQL, quite a bit of the same techniques that you use for modeling data can be leveraged. There are one or two things that you cannot, but I mean, I'll just take Elasticsearch as an example. When Elasticsearch doesn't have joins, but will support, let's say, very complex JSON data types and parent-child relationship and things like that. Now data modeling is like this extremely hard thing, right? Where you're literally translating between two languages that don't speak the same words. So everything gets kind of wedged into one and it gets very awkward very quickly. But if the destination system has a concept of tables and other you have many different different data that can be modeled in different tables, and you can join when you query them, so you don't have to kind of like squish them into the same table. And so that I think releases a lot of the complexity and kind of like eliminates it almost by definition. So I think a lot of that is applicable. I would say the core things that you have to understand is in real time is when you are using SQL, and let's just take this other example I said, where you kind of have real time streams coming in and you're kind of aggregating that into the metrics that you want to do alerting or anomaly detection on. In real time, there are a couple of things that comes up. One is out of order arrivals, right? So in batch, you don't have to think about out of order arrivals, which is, well, once every night, a big truck of data backs up into the warehouse and just dumps everything. It's like, okay, there is no out of order. Out of order happens like maybe intra hour, intra minute, but by the time it all gets aggregated and dumped into the warehouse, it's all gone, right? So then how do you deal with out of order arrivals is one important thing. And at the end of the day, why do the old school, the previous generation of real-time systems made that hard, is because they would assume that the data is immutable. As in, once you write the data, you can't change it. And if you can't change it, well, then the order matters, because I already have written that in the last minute, there were only 72 transactions that came through or orders that were placed. Well, the 73rd orders, for whatever reason, came 3 minutes later. Now I can't go and update that metric because it's immutable, once the minute is done. And this was one thing that we realized very early on, that mutability is a very important requirement. And coming full circle, RocksDB allows us to build a mutable real-time database at scale and still keep it very, very efficient. So that I would say is a very key tenet, where mutability makes things easier. And so when it comes to data modeling, you should demand that. And that also makes it, makes modeling simpler. So out of order arrivals, make sure that to keep modeling simpler, you pick a database that supports mutability. Then the second one that I would say comes up that makes modeling very hard is detecting duplicate arrivals, right? When you're aggregating real-time data continuously, some metric somewhere, something is going to get duplicated. And you thought you did in a real time, you do 1 minute aggregations and you think you did 72, but it was actually only like 68, and there were like 4 duplicates. How do you detect that? So this is where a lot of the streaming platforms talk about exactly one semantics versus at least one semantics, and so that I think is important to track. I think a lot of the data sources have to track what we call like a unique ID per event, and you need downstream systems to understand what unique events has it already processed, so that when the duplicates come, they can ignore it, as opposed to thinking that it's another additional event. And so So there's lots of different techniques that are available in these kind of streaming technologies, and using them correctly while you're modeling the data, I think is very important. And again, Rockset gives you this out of the box. So the reason why we are able to do that is Rockset also comes in with these built-in data connectors. And so when you connect Rockset to, let's say, Kafka or Kinesis, it already taps into a unique ID that these underlying systems have for these underlying messages. And so any part in the pipe, in that whole infrastructure, that is taking data out of Kafka and feeding it into Rockset to turn them into analytics and metrics and what have you, understands that we need to have exactly one semantics, and that is built in. So you don't have to do any, your data modeling continues to be, okay, I have some data, it's just coming in as a stream, I'll model it as a table or aggregate a table, and I want to keep these dimensions and these metrics across all of those dimensions. And you can just represent all of that in with just SQL. And so, so I think we strongly believe, again, going back to why SQL is important, you should be able to model all your data simply using SQL and not have to worry about these real-time specific problems like out-of-order arrivals or exactly one semantics, and which is why Rockset is built this way.
Does that get expensive though? I assume that means that if you have like a certain buffer window where you're saying, all right, I'm going to deduplicate and I'm going to keep track of duplicates over the course of an hour, that means that you have to maintain a buffer of all those unique IDs for that hour. So are there cases where that just gets too expensive and it's not possible anymore?
100% right. If you actually have a unique ID that is completely random, all the streaming platforms actually have more stronger guarantees than that, where they have a bunch of partitions and every partition has a monotonically increasing number as an ID. And so the downstream systems only have to remember the high water mark. They don't have to remember every drop of water that came through. And so remembering the high water mark and making sure that should always be going up, I think is a much, much, much more efficient way to do it. And again, these are all the subtleties where if you are DIYing your own real-time stack, a lot of these complexity will start hurting, and then suddenly, like, the metrics that is coming out of the system, people won't trust it because there's these edge cases where you don't get it right. And again, that eliminating the complexity and providing very, very accurate metrics, even when there are out of order arrivals and duplicate arrivals, is really, really important. So there are definitely ways to do it where handling any of these things could become very, very, very expensive. But again, we have this unfair advantage that the database company is also building that connector kind of pipe, and so we know how to kind of wire these high watermarks and the last message, the highest message number that has been processed from every partition, and that metadata is kind of like plowed through end to end on the data connector stack, so that the database knows when it's processing a new record that it has to process versus when it is getting a duplicate that it can conveniently ignore.
Okay, and so the goal, in some sense, is that Rockset can kind of speak the native language, so to speak, of these different systems you're connecting into, and so you're using, like, for example, PubSub native semantics or Kafka native semantics to track potential duplicates, so you're not having to do a lot of extra work.
Yes, absolutely. I think data modeling, again, going back, look, I think if it's like rent a U-Haul to go to the edge of town to get next day shipping or something, right? Like it has to be as simple, right? Like real time has to be just as simple and just as powerful as everything that you took for granted in batch world have to be available in terms of full feature SQL and all the other advantages that come with it. Not just that I can ask very complex analytical questions, but I can also model my data in a way that makes sense to everybody. And even that, I think you should be able to do that using SQL and not like some DSL or some, archaic, API that is very, very specific to a particular system. You should kind of like not really fall for any of that, because that's where complexity creeps into your system.
We're just about to the hour here. It's not a hard stop, but is there anything else you want to talk about before we close out for the day? Thank you so much for joining us. This has been an exciting conversation, both specifically with regards to Rockset and just more generally regarding the kind of real-time transitional conversation. But yeah, what else is on your mind before we shut it down for the day?
I feel like I don't know where the hour went. I feel like we could be doing this for another many hours. And so thank you for hosting me. I think we covered most of the questions. I would say I would add one thing, which is people ask, like, how does it change for IoT data? And do I need to do some edge analytics? I think it really, again, depends on what your IoT data is and what you do with it eventually. There are IoT data that comes out of a factory where, the factory floor, people on the factory floor needs to be immediately alerted if some, gas or some state is getting toxic for the people there and unsafe for the people there. You don't want to send anything to the cloud there. You don't want to say, oh, my ISP got in the way for me protecting my. No way, right? Like, it all have to be a closed system there, and extremely tested. And the good thing you have there in those kinds of IoT is that you don't need it to be, elastically scalable. Suddenly there's going to be a flash flood of data. There is that number of sensors, that much sending that much amount of data, and so you can kind of process and provision everything over a longer period of time, because the factory is probably not constantly adding capacity like every day or every hour. And so that, I think, is really important, what you do with that IoT data. But there is tons and tons of IoT data use cases where streaming them to the cloud and doing processing there is the right thing, or is the beneficial thing. And I'll give you an example: a buy now pay later company processing transactions. At the end of the day, it's IoT data, because it's point of sale devices producing these records that gets logged and tracked. And so there, I think you're trying to protect the business, and you can only get that information when you aggregate these from all these sources. And so it really depends on just the fact that the data is generated by IoT device is not as interesting as what you do on what you want to do with it, and what kind of applications you're building on top. And if you were to solve it, if the needs are that your application needs to solve it in the cloud, I would say take a look at a Rockset. There's a free trial, $300 worth. You can go to rockset.com and start a trial and get a feel for yourself. So if you're solving any real-time analytics use cases in the cloud, give Rockset a shot, and you'd be pleased.
Thank you so much. Yeah, it's been a pleasure having you on. And the IoT comments are interesting, because I often, when you talked about a factory, a lot of those applications can just run on Postgres. Going back to Postgres, like, it's just one factory, Postgres will be fine. But any like mobile app on a phone is actually already an IoT application, and can potentially benefit from this kind of scale, because you can easily, very quickly hit millions of users. Fantastic. Well, thank you for being on, and we'll have to have you on another time, like in a year or something like this, and kind of check in on the state of the world at that point, and have another discussion about the state of streaming. And let's see, I think next week we have Scott Taylor coming on, and so I think Joe will be posting an announcement of that soon, and I'll get this up on YouTube as well if people want to watch it after the fact. And thanks again, Venkat. Really appreciate your time. I know you've got an insane amount going on with the new year and just running a very successful startup, and so yeah, it was really a pleasure.
Thanks, Matt. Really appreciate it, and I'll come back anytime. Just ping me. Thank you.
Sounds great.